All right, welcome to Lesson 2, Velocity, example number 3. This is the last example for this lesson, and it's going to be discussing the relevance of the slope on a position time graph. No surprise with the name of this lesson is that the slope of a position time graph correlates to the velocity of our object. What I have drawn out on my screen here is I've roughly drawn out the graph that's in the workbook. This by no means is to scale, but it's roughly the same graph. We've got position in kilometers along the y-axis. We've got time along the x-axis. And funny enough, if we were to find the slope of a line here, we would have rise over run, position over time. Units are kilometers per hour. That's what the units of the slope would work out to be. Okay, kilometers per hour being a measurement for velocity. So how do we find the slope? Well, what we need to do is we need to find ourselves a line of best fit. I happen to have this handy ruler tool. You likely are going to be choosing to use a real ruler. And we're going to attempt to get a line that goes basically right down the center of this. We want to have about equal spacing of as many dots as possible on either side, and at the same time touching as many dots as possible. So for me, this is what my line of best fit is going to be. Yours is going to be eyeballed a little bit, but you should within a few percent be able to get the same values as me. All right, I'm going to choose a color here. I'm going to choose red. I need to turn the black to red. There we go. And there is my line of best fit. Now, I'm going to be using values for my line of best fit from my workbook. So these values that I'll be using are going to be fairly accurate. Let me see here. So one value that I pulled off of this line was somewhere around here. It was actually at the value of 5, so probably around here. And what I got for that is I got a value of 5 and 64. So you can see it's not quite right, but it might be pretty close. Then up here, to find a nice slope, you want to find values that are far apart on the line to get a more accurate slope. So up here at 37, so maybe somewhere around here. I'll put a dot there. This value I had 37 and 148. Great. We need 2 points to find the slope of a line. The formula that we're going to use to find slope, you've probably seen before. Slope of a line is equal to rise over run. But if we're using point values, it's going to be equal to y2 minus y1 over x2 minus x1. Well, we have 2 points now. We just found them. Drew a line of best fit, found points. Essentially, we can integrate these points into this formula now. So we can now say our slope is equal to, I'm going to say this is my number 2 value, this is my number 1 value. So it's going to be 148 minus 64. Those are my 2 y values. Divided by 37 minus 5. So our slope of this line is equal to 84. And I haven't been putting units on this, but maybe I could. Our y units are in kilometers. So really these two should both have kilometers on them. Kilometers, and this should have hours on it. So this is 84 kilometers over, this works out to what, 32? 32 hours. So our slope is equal to 2.625. 2.625, this would be kilometers per hour. That's close to our final answer. Do we have any value of sig figs here? Not really. But I can really only read this to 2 sig figs probably. This graph isn't super accurate. I'm going to round this off, and I'm going to say that the slope is equal to 2.6 kilometers per hour. That's our final answer. I have one more small note on this problem that I forgot to point out at the beginning. On our graph in your book, there is an outlier point. And it's way out. It's somewhere, it's like down here. And it doesn't really fit in with everything else. Well, this point down here, we're going to call that an outlier. Why? I think it's I. Outlier. I don't know how to spell it. Regardless, this point likely is due to an error in measurement. It's tough to say, but it doesn't fit the trend of the rest of our data. So we're going to sort of ignore it here. So let's just leave that one out. Okay, that's the rest of lesson number 2.